So in this video of quadratics, what we're going to be doing is taking a look at factoring. Factoring is one of the methods that we use to find the solutions or roots, and it's also a very important technique to have in one's mathematical arsenal. This is Algebra 1, Erudition Education. Let's get started. So first, let's answer the question, what is factoring? So when we factor, we express something as a product of it in its simplest terms. So if I have A, B, C, by factoring it, I would be breaking it down into A times B times C. The definition for factoring is common to both polynomial and numerical factorization. So this definition, or this idea of factoring, is the same to both x squared and 49. The method is the same and the definition is also the same. Similarly to how numbers can be factored into their simplest form, we can do the same thing with polynomial expressions and thus quadratic equations. So, likewise to how I can factor 4 into 2 squared, I can factor x squared into x times x. So let's look at factorization in quadratics. In quadratics, we use factorization to find the solutions to a quadratic equation, also known as the x-intercepts. While factoring can be a very efficient way to find the solutions for quadratic equations, not all quadratic equations are actually factorable. When we have quadratics that are factorable, we are able to find the roots easily by factoring the quadratic and then setting the expression equal to 0. In this video, we'll be learning about factorization in quadratic equations with an a, or coefficient on the x squared term, value of 1, and how to factor these quadratic equations to find the roots or solutions of the quadratic equation. So let's look at the factored form of a quadratic equation. The factored form of a quadratic equation is y equals a times x minus p times x minus q, where a is a constant and p and q are the roots. Once again, as in the standard form for a quadratic equation, a cannot be equal to 0. If a is equal to 0, this entire expression will equal out to be 0 and it will not be quadratic. When we use quadratic equations in a factored form, we immediately know the values of the roots, as can be seen here. When we have it in this factored form, we can immediately see the roots, which are p and q. The more difficult part is actually factoring the quadratic equations from the standard form, or converting it from standard form to factored form. But we have theorems which make this easier. So let's look at Vieta's theorem. The Vieta's formula states that for the standard form of the quadratic equation, ax squared plus bx plus c, with roots / solutions of p and q, that p times q is equal to c over a in the standard form, and that p plus q is equal to negative b over a. Using this formula, we can easily factor and find the roots of the equations given the factored form y is equal to a times x minus p times x minus q. So using this Vieta's theorem, we can find the roots and plug them back in to the factored form of a quadratic equation to get the quadratic equation in factored form. In this video, we're only going to be solving and factoring quadratic equations with an a value of 1, utilizing the Vieta's theorem in factored form of a quadratic equation. So let's look at our very first example. We need to factor x squared plus 6x plus 5 and find the roots. Using Vieta's theorem, we get the roots p and q, and their sum, p plus q, is equal to negative b over a. In this case, the b value is 6. So, p plus q is equal to negative 6 over the a value, which is just 1. So therefore, we will get that p plus q is equal to negative 6. Now let's look at the second part of the Vieta theorem. The Vieta theorem states with p and q roots, p times q is equal to c over a. In this case, my c value is 5 and my a value is 1. So therefore, p times q is equal to 5. Now we just need to look at two numbers that come up with these sum and product. In this case, these two numbers will be -5 and -1. As we can see, -5 times -1 is 5, and -5 minus 1 is equal to -6. Therefore, our roots are -1 and -5. Now, we must plug these back into the factored form of a quadratic equation to get the quadratic equation from standard form to factored form. We will get y is equal to x minus -6, the first root, times x minus -1, the second root. This is -5, by the way, I made a mistake. So y is equal to x plus 5 times x plus 1. And this is the factored form of this quadratic equation. Let's look at example number 2. Factor the quadratic equation y is equal to x squared minus 3x minus 4, and find the roots. Once again, using Vieiras theorem with roots p and q, we know that p plus q is equal to -b over a. In this case, my b value is -3. So therefore, I'll get p plus q is equal to 3 over my a value, which is 1. Also given by the Vieta theorem, with roots p and q, I know that p times q is equal to my c value over a. In this case, my c value is -4, and my a value is 1. So therefore, p times q is equal to -4. Once again, we need to find two numbers that have a sum of 3 and a product of -4. In this case, we will get roots 4 and -1. As we can see here, 4 minus 1 is equal to 3, but 4 times -1 is equal to -4. Therefore, we have these, which we can plug into our factored form for a quadratic equation. So we get y is equal to x minus 4 times x minus -1. We plug in the roots and we will get our final answer. Y is equal to x minus 4 times x plus 1. And that is this quadratic equation in factored form. Let's look at our third and final example. Factor and find the solutions to the quadratic equation y is equal to x squared minus 10x. So in this case, it is much simpler to factor since we have no c value. Since we see that there is an x in both of these terms, we can factor out an x and get x times x minus 10. And this is the factored form. From here, we need to see at which values this equation will equal 0. So we can set it equal to 0. Once we set it equal to 0, we can see that when x is 0, or when x is 10, this equation will be equal to 0. When x is 0, this will be 0 times -10, which is 0. And when x is 10, we will get 10 times 0, which is 0. We can find this using the zero product property. So from here, we know that this is the factored form of this equation, and the roots are 10 and 0. So now let's conclude this video with the other areas of factoring. In this video, we only covered the factoring of quadratic equations with a values of 1. However, quadratic equations, as we covered in our introduction video, can have any real a value as long as it's not 0. In the next factoring videos, we will learn about the factorization of more complicated quadratic equations, such as those with a values other than 1. In addition to this, we will also learn about special product rules, which can be useful to expand or factor quadratic equations and to find solutions. Thank you. This was Erudition Education. Please be sure to leave a like or dislike and leave a comment based on anything you want to see more on this topic or any other topics you feel that we should cover. Please hit the subscribe and bell icon, and bye till next time.